Okay, so today what we're going to work on is the review for test number 5. So the first one is we have to graph the rational equation using vertical asymptotes, holes, horizontal asymptotes, x-intercepts, y-intercepts, and points to help us graph it. We are not using a calculator for this. Okay, so let's take a look at 1a. So 1a is f of x is equal to 3 over x minus 2. So I notice that this is not factorable, so that means there's not going to be any holes. So my vertical asymptote, I take the denominator, x minus 2, and set that equal to 0. So my vertical asymptote is x is equal to 2. Okay, so now let's do our horizontal asymptote. So our horizontal asymptote, right, we look at the degrees. So the degree in the numerator would be 0 because there is no x, so that's x to the 0 over x. So the degree to the first. So the degree in the denominator is bigger than the degree in the numerator. So that means my horizontal asymptote is y is equal to 0. Okay, so now let's try to find our x and y intercept. So our x-intercept is when y is equal to 0. So I have 0 is equal to 3 over x minus 2. Put that 0 over 1 across multiply. So 0 times x minus 2 is just 0 equals 3. So that doesn't make sense. So that means there's no x-intercept. So let's see if there's a y-intercept. That would be when x is equal to 0. So I have y is equal to 3 over 0 minus 2. So y is equal to 3 over negative 2. So my y-intercept would be 0 comma negative, that's 1.5. All right, so let's start graphing. See what we have so far. Okay, so let's graph the vertical asymptote at x is equal to 2. Okay, so that's x equals 2. Our horizontal asymptote is at y equals 0. That's right along the x-axis. All right, so that's y equals 0 there. All right, so I have a y-intercept at 0, negative 1.5. So that's right there. So the graph will cross there. Now I need to get some other points here. So I'm going to make a little table of values. So I have an x column, 3 over x minus 2. I'm going to evaluate, and y. So let's see. Let's take a point to the left of this. So let's do negative 1 and let's do negative 3. And then we'll do 1. And let's see what's happening on the other side. So we'll do 3 and 4. All right, so we're going to use, let's do negative 3. We'll do negative 1. We'll do 1, 3, and we'll also do 4. Okay, so we're going to plug our x's in. So it's 3 over negative 3 minus 2. So that's 3 over negative 5. So that's negative 0.6. All right, so let's graph that. So I have 3, negative 0.6. So it's a little bit below the x-axis. So now let's try negative 1. So I have 3 over 1 minus 2, negative 1 minus 2. So that's 3 over negative 3, which is negative 1. So I have negative 1, negative 1. Okay, so let's try 1. So I have 3 over 1 minus 2. So that's 3 over negative 1, which is actually negative 3. Negative 3 there. Okay, so we have 1, negative 3. So on the left side here, this graph is going to look like this. Okay, so now let's start with 3. So I have 3 over 3 minus 2. So that's 3 over 1. So that's just 3. So I have 3, 3. All right, let's try 4. So I have 3 over 4 minus 2. So that's 3 over 2, which is 1.5. So we have 4 and 1.5. So that means this graph is going to go like this. Okay, so let's take a look at the next one. Okay, so letter B is f of x is equal to x squared plus 2x over x squared minus 4. So I noticed right away that I can factor this. So I'm going to factor the GCF in the numerator is x times x plus 2. And the denominator factors, that's dots, x plus 2 and x minus 2. So I noticed that I can reduce the x plus 2 and the x plus 2 here. So that means I have a whole. So this cleans up to be x over x minus 2. So I have a whole. All right, so let's do our whole and our vertical asymptotes here. Okay, so our vertical asymptote is going to be x minus 2 equals 0, so x equals 2. And then we're going to have a whole. Our whole is going to be at x equals negative 2. Now I have to find the y value so I can plot the point. So I plug it into this, the cleaned up version, to get my y. So it's negative 2 over negative 2 minus 2, which is negative 2 over negative 4, which is positive 1/2. So my whole is at negative 2 comma 0.5 or 1/2. Okay, so now I need my horizontal asymptote. So my horizontal asymptote, so I have x squared over x squared, right? So they both have 1. So when the degree in the numerator is equal to the degree in the denominator, they think of it as they cancel out. So I'm only left with the coefficients. So that's y is equal to 1. All right, so let's do our x-intercept. That's when y is equal to 0. So I have 0 equals x squared plus 2x over x squared minus 4. So you cross multiply. So I get 0 is equal to x squared plus 2x. 0 equals x times x plus 2. So I get x equals 0 and x is equal to negative 2. But we actually know at negative 2 it's a whole, so that's not going to work. So my x-intercept is at 0, 0. All right, so now I need my y-intercept. That's when x is equal to 0. So I get y is equal to 0 squared plus 2 times 0 over 0 squared minus 4. So that's just y is equal to 0. So 0, 0 is my y-intercept. Okay, so let's start graphing. Okay, so let's graph our whole and our vertical asymptote. So the vertical asymptote is at x equals 2. There's a whole at negative 2 comma 0.5. I have a horizontal asymptote at y is equal to 1. Okay. And now I just need to make a table of values to find some more points. Okay, so we're going to have an x column. I'm just going to make a little bit more room here. Alright, so I have x. I'm going to use x squared plus 2x over x squared minus 4 and y. Alright, so I need to the left of my whole, so I'm going to use negative 3. I'm going to use to the right of my whole, which is negative 1. I'm going to use 0, 1, and then to the right of my vertical asymptote, so we'll use 3 and 4. And we'll squeeze in 4 down here. Okay, so let's start with 3. So I have 3 squared is 9. Negative 3 squared is 9. 2 times negative 3 is negative 6. Over negative 3 squared is 9 minus 4. So that's 3/5. So that's 0.5. So I have negative 0.6, sorry. So it's negative 3 comma 0.6. So the whole was at 0.5, so it's a tiny bit higher than whole. All right, so at negative 1, so I have negative 1 squared is 1. 2 times negative 1 is negative 2. Over negative 1 squared is 1 minus 4. So 1 minus 2 is negative 1 over 1 minus 3 is negative 3. So it's positive 1/3. So I have here negative 1 and 1/3 is about 0.3. Oh, I forgot to put my my intercepts. I apologize for that. I forgot my intercepts. So I have an x-intercept and y-intercept are at the same exact place. So that would just be right there. So I have my 0. That's 0 there. So now I need 1. So I have 1 squared is 1. 2 times 1 is 2. Over 1 squared is 1 minus 4. So that's 3 over negative 3. So that's negative 1. So that's 1, negative 1. Okay, so I know this graph is going to look like, don't go through the hole. So it'll look like that. All right, so let's try 3. So I have 3 squared is 9. 2 times 3 is 6. So it's 9 plus 6 over 9 minus 4. So that's 15 over 4. And 15 over 5, sorry, is 3. So it's 3/3. All right, so now we're going to do 4. So 4 squared is 16. 2 times 4 is 8. So it's 16 plus 8 over 16 minus 4, which is 12. So we have 24 over 12, which is going to be 2. So that's 4/2. So it's going to look like this. Okay, so that's it, and let's take a look at number 2. Okay, so number 2 is given the functions f of x and g of x, we want to do the composition. We want to do f of g of 5 and g of f of x. All right, so remember, when we do f of g of 5, we're first going to take 5, plug it into g, then take our answer and plug it in for f. All right, so let me write these functions. So f of x is equal to 3x plus 6. G of x is equal to x squared plus 2x minus 1. All right, so the first thing we want is f of g of 5. So we're going to start with g of 5. So I go to my g function. Wherever I see an x, I plug in 5. So it's 5 squared plus 2 times 5 minus 1. So that's 25 plus 10 is 35 minus 1 is 34. So now I want to find f of 34. So I go to my f function. Wherever I see an x, I plug 34 in. So it's 3 times 34 plus 6. So we get f of 34 is equal to 108. So f of g of 5 is equal to 108. All right, so let's take a look at the next part. So I'm just going to rewrite f of x. So f of x is equal to 3x plus 6. And g of x is equal to x squared plus 2x minus 1. And we're looking for g of f of x. So I'm just going to replace f of x with what it's equal to. I'm going to do a substitution. So it's g of 3x plus 6. So what this means to do is to go to my g function. Wherever I see an x, I'm going to plug in my input, which is 3x plus 6. So it's going to be 3x plus 6, and it says to square my x, plus 2 times 3x plus 6, and then I have minus 1. Alright, so let's start with 3x plus 6 times 3x plus 6. So that's 9x squared plus 18x plus 18x plus 36. Distribute the 2. So we get 6x plus 12, and then I have minus 1. So we'll combine like terms, so I have 9x squared. So 18x and 18x is equal to 36x, plus 6x is 42x. Right, so I did those. So now I have 36 plus 12 is 48, minus 1 is 47. Okay, so let's take a look at 3. Okay, so number 3 is to expand the binomial. So that's the one where we use NCR, PTR, Q to the n minus r. It's the binomial expansion. Okay, so the first one is, so remember we're using NCR, P to the r, Q to the n minus r. Alright, so for the first one we are doing here x minus 3 to the 4th power. Okay, so we have n is going to be 4, that's your exponent. R is your exponent down to 0, so it'll be 4, 3, 2, 1, 0. P is the first term, which is going to be x. Q is the second term, which is going to be negative 3. Alright, so we're going to start with 4C4. And then it'll be 4C3. 4C2, 4C1, and then you have to go all the way down to 4C0. Alright, and then it's P. P is x, so it's going to be x to the 4th, and then it'll be x to the 3rd, x to the 2nd, x to the 1st, x to the 0. And then my Q is negative 3, so it's negative 3 to the 0. Negative 3 to the 1st, negative 3 squared, negative 3 to the 3rd, and negative 3 to the 4th power. Okay, so remember, this is all multiplying here. So 4C4 is 1, x to the 4th is just x to the 4th, negative 3 to the 0 power is 1, so then this is just x to the 4th. 4C3 is 4. X to the 3rd is just x to the 3rd times negative 3 to the 1st is negative 3. So this is negative 12 x to the 3rd. 4C2 is 6 times x squared. Negative 3 squared is 9. So this is 54x squared. 4C1 is 4 times x times negative 27. So 4 times negative 27 is negative 108x. And then 4C0 is 1 times, sorry, this actually should have been 0 here. This should have been 0, sorry about that. Times 1, because x to the 0 power is 1. And then negative 3 to the 4th power is 81. So this is 81. And the last thing is you have to remember, you have to write it as the expansion of the binomial. So you have to put it now in order. X to the 4th minus 12x cubed plus 54x squared minus 108x plus 81. Okay, so let's take a look at B. Okay, so B is, my binomial is 3x plus 2y squared cubed. Alright, so n is going to be 3. That's your exponent. R is your exponent all the way down to 0. P is the first term, which is 3x, and Q is the second term, which is 2y squared. Okay, so we're going to start with 3C3, and then we'll do 3C2, 3C1, and 3C0. Alright, and then P is 3x, so it's 3x to the third, 3x squared, 3x to the first, and 3x to the 0. Q is 2y squared, so that's going to be raised to the 0 power. 2y squared to the first, 2y squared to the second, and 2y squared to the third. Alright, 3C3 is 1 times 3x cubed is going to be 27x cubed. And 2y squared to the 0 is 1, so that's 27x cubed. 3C2 is 3. 3x squared is 9x squared. 2y squared to the first is 2y squared. So this is going to give me 3 times 9 times 2 is 54. So it'll be 54x squared y squared. It's a square in there. 3C1 is 3. 3x to the first is 3x. 2y squared is 4y to the fourth. So 3 times 3 is 9 times 4 is 36xy to the fourth. And the last one, 3C0 is 1. 3x to the 0 is 1. 2y squared to the third is 8y to the sixth. Alright, so my final answer is going to be 27x to the third plus 54x squared y squared plus 36xy to the fourth plus 88y to the sixth, because this was 8y to the sixth here. Okay, so let's take a look at 4. Okay, so 4 is to factor completely. All right, so I have x to the third minus 64. That is not the difference of two perfect squares. It is the difference of two perfect cubes. So let me write that down. X cubed minus 64. So remember, the difference of two perfect cubes, remember we use SOAP. Remember, same, opposite, always positive. So we get small parentheses, big parentheses. So same sign, opposite sign, always positive. In the parentheses, it's AB. In the second parentheses, the front ends are your AB squared, and in the middle is AB. So now we need our A and our B. So A is the cube root of x to the third, which is x. B is equal to the cube root of 64, which is 4. Once you have that, it's just plugging it in. So it's x minus 4 times x squared plus 4 times x is 4x, and then 4 squared is 16. Okay, so let's take a look at part B, sorry. Okay, so B is 2x to the third plus 16. So remember, we're using SOAP here. All right, so I do notice there is a GCF, and the GCF is 2. So now I have the sum of perfect cubes. So small parentheses, large parentheses, same sign, opposite sign, always positive. Remember, A squared, B squared at the ends, and then AB in the middle. The cube root of x cubed is x. This is my A. The cube root of 8 is 2, and this is my B. So I have x plus 2 times x squared minus 2x plus 2 squared, which is 4. And then don't forget to bring down the GCF, which is 2. Okay, so let's take a look at 5. Okay, so 5 is another evaluation, but it is a piecewise function. So you just have to make sure you plug in your input into the right equation because there's restrictions on these equations. So for this part of the function, f of x equals 3x plus 4, your x's have to be less than -1. And for this part of the function, f of x equals x squared plus 5x minus 2, your x has to be greater than or equal to -1. All right, so let me just rewrite that. So I have here f of x is equal to 3x plus 4, and x has to be less than -1, and x squared plus 5x minus 2, and x has to be greater than or equal to -1. Okay, so for the first one, we're looking for f of -1. So I have to see where it falls. My x has to be is -1. So does it fall in as x is less than -1 or x is greater than or equal to -1? Since x is -1, it falls right in here, so I have to plug it into the bottom part. So it would be -1 squared plus 5 times -1 minus 2. So f of -1 would be equal to -6. All right, so now we're going to do f of -3. So -3 is less than -1, right? X is right in here. So I plug it into this one here. So it's 3 times -3 plus 4. So f of -3 is equal to -5. Okay, next one. F of 0. So 0 is greater than -1. So I have to plug it into the bottom one. So it's 0 squared plus 5 times 0 minus 2. So f of 0. Sorry, f of 0 here. So f of 0 is equal to -2. And the last one is f of 2. So f of 2 is greater than -1. It'll fall in here, so it plugs into that one. So it's 2 squared plus 5 times 2 minus 2. And that comes out to be 12. So f of 2 is equal to 12. Okay, so let's take a look at 6. Okay, so 6 is to write the equation of a line in point-slope form, and then put the equation in slope-intercept form. And then we have these certain pieces of information that we have here. All right, so first of all, let me write down what the two equations are. So point-slope, that's y minus y1 equals the slope times x minus x1. Slope-intercept, that's y equals mx plus b, right? Because you have your slope and your y-intercept. All right, so the first one is we want to go through the point -3, 2, and have a slope of 1/2. So we want to put in, use point slope, put in point slope, and then put in slope intercept. So this is my x, this is my y, x1, y1, sorry. So it'll be y minus 2 equals my slope, which is 1/2 times x minus -3. Okay, so that's point slope form. Now I want to put in slope intercept form. So I distribute. And this will be plus 3. So it's y minus 2 equals 1/2 x plus 3/2. Add 2 to both sides. So I get y equals 1/2 x plus 7/2. That's slope intercept form. Okay, so now what happens when we have the 2 points? All right, so if I only have 2 points, but I have to find the slope. Once I get the slope, I could plug my slope in, and then I could pick either point I want and plug it in for x1 and y1. So remember the slope formula is y2 minus y1 over x2 minus x1. So we have to find the slope. All right, so I have -1 minus 3 over 9 minus 0. So that's -4 over 9. All right, so my point slope is going to be, so you can pick any point you want. I'm going to pick this point because it is 0 to make things a little bit better. So I have y minus 3 equals my slope, which is -4/9 times x minus 0. So that's my point slope. Now, slope intercept, you're going to now distribute the -4/9. Y minus 3 equals -4/9 x. And this is nice because then I get 0 here, plus 0. Add 3. I get y equals -4/9 x plus 3. All right, so let's take a look at number 7. Okay, so number 7 here says put the function in vertex form, then identify the vertex. Okay, so remember, this is vertex form. F of x is equal to a times x minus h squared plus k. hk is the vertex. So you change h, but you keep k. All right, so let's take a look at the first one. So that's f of x is equal to x squared minus 8x plus 10. So you have to complete the square. My leading coefficient is a 1 here, so that's good. So I minus 10. F of x minus 10 equals x squared minus 8x. So now I do half of -8. -4 squared is positive 16. I add that to both sides. F of x minus 10 plus 16 equals x squared minus 8x plus 16. So then I get f of x is plus 6 equals x minus 4 squared. So then I minus 6 from both sides, and I get f of x is equal to x minus 4 squared minus 6. So my vertex is positive 4, negative 6. Okay, so let's take a look at B. All right, so B is f of x is equal to negative 2x squared plus 6x plus 3. All right, so the first thing is I want to divide everything by -2 because my leading coefficient has to be a 1 in order to complete the square. So I have f of x over -2 equals x squared minus 3x minus 3 halves. And you leave it as a fraction. Do not put in a decimal. All right, now I add 3 halves to both sides. F of x over -2 plus 3 halves equals x squared minus 3x. Now I do half of -3 is -3 halves. Squared is 9/4. Add that to both sides. So f of x over -2 plus 3 halves plus 9/4 equals x squared minus 3x plus 9/4. Okay, so we want to combine like terms. So I have f of x over -2. So this combines and becomes 15/4. Equals, and I'll factor this. So that's x minus 3 halves squared. So minus 15/4 from both sides. So I get f of x over -2 equals x minus 3 halves squared minus 15/4. Now I need to get rid of the -2. So I multiplied this by -2, so that'll cancel. And I multiply both sides by -2 over here. So the -2 here just goes in front of the parentheses. So I have f of x equals -2 times x minus 3 halves squared. The negative 2 here, that becomes positive. All right, so that becomes positive. And then the 4 and the 2 reduce to 1 and 2, so it's positive 15 halves. All right, so my vertex would be positive 3 halves, comma 15 halves. Okay, so let's take a look at number 9. Okay, so number 8 is find the domain. So 8a is f of x is equal to the square root of 7 minus x. So sometimes it's easier to think of when you find the domain, what can't you have? So think of a square root, what can't you have? You can't have a negative on the square root. So the 7 minus x, in order for it not to be negative, it has to be positive. So that means it has to be greater than 0. And then you have to say to yourself, well, can it be 0? Yes, you can have the square root of 0. So this can be equal to 0 because the square root of 0 is 0. So I minus 7. So I get negative x is greater than or equal to negative 7. Divide by negative 1. Remember, when you divide by negative, flips the signs. So I have x is less than or equal to 7. So it's going from negative infinity to 7 is the domain. Okay, so let's take a look at b. So that's f of x is equal to 1 over the square root of 2x minus 3. So now I have two things going on. I have a square root, and so your square root has to be positive. Now it can't be 0 because you can't have 0 in the denominator. So it has to just be greater than 0. So we have 2x is greater than 3. X is greater than 3 halves. So it's from parentheses 3 halves to positive infinity. Okay, so let's take a look at number 9. All right, so number 9 is to write the polynomial function whose zeros are, we have x is equal to 0 and x is equal to positive, negative, plus minus 4i. All right, so the x equals 0 here, there's nothing to do because that's my factor. Over here on the right, I have to square both sides. So I get x squared is equal to 16i squared. And remember, I squared is negative 1, so that's negative 16. So I have x squared plus 16 here. Now I take my other factor, x, and multiply them together. So I get x cubed plus 16x, and it has to be represented as a polynomial function. So it's f of x equals x to the third plus 16x. All right, let's take a look at number 9b. All right, so my zeros are x equals negative 1 and x is equal to 2 plus minus 3i. All right, so this guy here on the left, my factor is x plus 1. This guy here on the right, I have to minus 2 and now square both sides. So when I square x minus 2, I get x minus 2 times x minus 2. Equals 9i squared. So when we double distribute, we get x squared minus 4x plus 4 equals negative 9. I have to add 9 to both sides, so I get x squared minus 4x plus 13. All right, now I need to multiply that by x plus 1. All right, so we will distribute. All right, so when I distribute here, I have 1 times 13 is 13. All right, so that's positive 13. 1 times negative 4x is negative 4x. 1 times x squared is positive x squared. X times 13 is positive 13x. X times negative 4 is negative 4x squared. X times x squared is x to the third. So I get f of x equals x to the third minus 3x squared. Sorry, minus 3x squared plus 9x plus 13. Okay, so let's take a look at 10, last one. All right, so number 10, I have the polynomial equation, the polynomial function x to the fourth minus 3x to the third minus 4x squared plus 18x minus 72. All right, so I want to use the remainder theorem to find the zero of the function, use synthetic division to break down the polynomial further, and then determine all zeros, and then list them as linear factors. All right, so you put this in a calculator, find where you think it crosses the x-axis, and it looks like it crosses the x-axis at, let's see what we have. Looks like f of negative 3 is equal to 0. All right, so we're going to do f of negative 3. So you plug it in. Negative 3 to the fourth minus 3 times negative 3 cubed minus 4 times negative 3 squared plus 18 times negative 3 minus 72. And we get 0. So I have x equals negative 3 is a 0. That means x plus 3 is a factor. All right, so now we're going to use synthetic division. So I put negative 3 on the outside, put all my coefficients, 1, negative 3, negative 4, 18, negative 72. So we have here So I have 1 times negative 3 is negative 3. Negative 3 plus negative 3 is negative 6. Times negative 3 is 18. Negative 4 plus 18 is 14. Times negative 3 is negative 42. Plus 18 is negative 24. Times negative 3 is positive 72, and I get 0. Okay, so now what I have is, my function now is f of x is equal to x plus 3 is a factor, and now I have x to the third minus 6x squared plus 14x minus 24. All right, so now I need another 0 to break it down a little bit more. So I'm going to do f of 4. So then I plug 4 in, and that comes out to be a 0. So that means x equals 4 is a 0, and x minus 4 is a factor. Okay, so we're going to break it down. So I have 4. I use this here now. 1, negative 6, 14, negative 24. So I have 1, 4, negative 2, negative 8, 6, 24, and I get 0. So my polynomial function so far is x plus 3, x minus 4 factor, and now we have this here, x squared minus 2x plus 6. All right, so now I want to find my zeros. So I set it equal to 0. Okay, so I make my t-chart, right? So I have my 0 here, negative 3, we have 4. Now I have to do this guy. That's not factorable, so you'd have to use quadratic formula to complete the square. So I'm going to complete the square. So I minus 6, so it's negative 6 equals negative 6. We have half of negative 2 is negative 1 squared is 1. Add that to both sides. X squared minus 2x plus 1 equals negative 6 plus 1. So I have x minus 1 squared is equal to negative 5. Square root both sides, I get x minus 1 equals plus minus the square root of negative 5. So x minus 1 is equal to plus minus I the square root of 5. Add 1. So you have 1 plus minus I the square root of 5. So these are my zeros. Sorry, just want to move this up. So here are my zeros. We have x equals negative 3, x equals 4, x equals 1 plus I the square root of 5, x equals 1 minus I the square root of 5. Now I want my linear factors. So this is x plus 3 times x minus 4. This is going to be x minus 1 minus I the square root of 5. And this would be x minus 1 plus I the square root of 5. And it says to write as a list. Oh, sorry, it just says to list linear factors. So that would be it. Okay, so if it says to write as a function of linear factors, then you would have to write f of x. Okay, if it says write it as a function of linear factors, so put f of, sorry, I can't fit it in there. So put in here f of x equals.
All right, so number 11 is to simplify each expression. All right, so I am dividing, we are multiplying here. So I am going to factor the numerator, the denominator of each one of these fractions and simplify. Okay, so in the numerator of the first fraction, I have 10x squared minus 10x to the third. So I notice that there is a GCF, and the GCF is 10x squared. So I'm going to factor out 10x squared, and then I'm left with 1 minus x. Okay, in the denominator, I have x squared minus 3x minus 54. So I'm going to factor the trinomial. So the trinomial factors and becomes x minus 9 times x plus 6 times, and then we have here x squared minus 36. That's the difference of two perfect squares. So that becomes x plus 6 times x minus 6 over, and then in the denominator I have 5x squared minus 5x. So there's a GCF, and the GCF is 5x. So it's 5x times x minus 1. So remember, we're reducing where there's multiplication. So there's multiplication in here, in between the 10 and the x squared, and x squared in the parentheses. In between these two parentheses, in between here, in between the 5 and the x and the parentheses. So remember, work from left to right in the numerator. So start with the 10 here. So I'm looking for something to reduce 10 with. So I have 5. 10 and 5 reduced to 2 and 1. I have an x squared here next, x squared. So I'm looking for another x squared or an x to the third, and I notice there's an x down here. 2 x's on top, 1 x on the bottom. Right? 2 x's on top, 1 x on the bottom. So one of them will reduce, and I'll be left with an x on the top. So one of the x's will reduce out, and I'll be left with x on the top and 1 on the bottom. I have next 1 minus x. I don't see 1 minus x down here, but I see x minus 1. These are opposites. Remember, opposites reduce to negative 1. So remember, I like to put the negative 1 in the numerator, but just don't put it in both numerator and denominator. The next thing I have is x plus 6. I'm looking for an x plus 6 or an opposite, and I see x plus 6, so that reduces to 1. They are the same thing. And then I see 6 minus x, but the only thing left in the new denominator besides 1 is x minus 9, so that does not reduce. So then my final answer is going to be, I have 2x times negative 1 times a 1 times x minus 6. So I have 2x times x minus 6 and a negative on the outside of that. Remember, I like to put it with the bar. And then in the denominator, I have x minus 9 times 1 times 1 times 1 times 1 is x minus 9. All right, let's take a look at 11b. Okay, so 11b is we are dividing rational expressions. So it's really basically the same thing as multiplying, but we have to make sure that we do same, change to multiplication, and flip the fraction. Okay, so it's same, change, flip. So I'm going to do that and factor at the same time. So x squared plus 9x plus 20, that factors and becomes x plus 4 times x plus 5. In the denominator, 7x to the third minus 56x squared. There's a GCF. The GCF would be 7x squared. So I have 7x squared times x minus 8 times, now when I flip, I'm going to put this in the numerator. So I'm factoring this to put into the numerator because I'm flipping. So x squared minus 3x minus 40 factors and becomes x minus 8 times x plus 5. And then the numerator goes into the denominator. I'm going to factor that trinomial, and that becomes x plus 5 times x plus 5. All right, now we're ready to reduce. Remember, there's multiplication here, in between the 7 and the x squared, and the parentheses and the x squared, and in between these parentheses over here. So remember, start in the numerator, work from left to right. I have an x plus 4. I'm looking for another x plus 4 in the denominator, or an opposite. I don't see it. So I move on to the next thing. I have an x plus 5. So x plus 5, and there's x plus 5 here. Reduces to 1 and 1. I have x minus 8. I see another x minus 8. They reduce to 1 and 1. I have another x plus 5 and another x plus 5 in the denominator. So they reduce to 1 and 1. So what's left? I have x plus 4 times 1 times 1 times 1. That's x plus 4. Over, in the denominator, I have 7 times x squared times 1 times 1 times 1 is 7x squared. All right, so let's take a look at number 12. Okay, so for number 12, it says to find the equation for the slant asymptote for each rational function. So remember, to find the slant asymptote, we are either going to do long division, or you could use synthetic division. Remember, we're looking for the quotient without the remainder. And you set it up as y equals. So for this is a nice one, because in the denominator here, my 0 would be x equals -1. So that's a nice number. I don't want to be using fractions, so I'm going to put -1 on the outside and use synthetic division for this. So it's 6, 7, and 4 here. Bring down the 6. 6 times -1 is -6. 7 minus 6 is 1. 1 times -1 is -1. So that's my remainder, my constant, my x. So then that would be 6x plus 1. And then this is my remainder, but I'm not using my remainder. So remember, your slant asymptote has to be y equals your quotient without the remainder. So it's y equals 6x plus 1. All right, let's take a look at 12b. Okay, so for 12b, notice that in the denominator here, I have a 6x plus 3. It would not be the best thing to use synthetic division, because we would have to be using fractions. I would have to -3 and divide by 6. So that would not be the best thing. So let's use long division for this. All right, so I'm going to put 6x plus 3 on the outside as the divisor there. And 54x squared minus 15x minus 19. All right, so 6x times 9x gives me 54x. So that's 54x squared, sorry. And then I have plus 27x. Remember, we are subtracting. So don't forget to do same, change, change. So change, change, change. So the 54x squared minus 54x squared. Negative 15x minus 27x, that is negative 42x. And then bring down the minus 19. And then 6x times -7 gives me negative 42. So that's minus 7 up here. Multiply that down. We get negative 42x and minus 21. Remember, parentheses. We're putting subtraction on the outside. We're doing same, change, change. Or distribute the negative. So that becomes a plus. This becomes a plus. This becomes a plus here also. Negative 42x plus 42x is 0. Negative 19. Sorry, just move that out of the way. Negative 19 plus 21 is positive 2. So that's my remainder. Positive 2 is my remainder, but that's not what I want. I don't want that part of my slant asymptote. I want this part up here. So my slant asymptote is y equals 9x minus 7. Okay, so that's it, and happy studying, and I'll see you tomorrow in class. Have a good night.